In DTF printing, powder is expected to attach only to printed ink areas. But in real production, powder often appears in places where no design exists. You may see a slight layer of powder on blank areas, or powder gathering along the edge of printed graphics. Sometimes the whole film looks slightly contaminated, and sometimes it only happens in certain sections of the roll. This usually becomes more obvious after coring or transfer, when the background is no longer clean. And this is not a rare defect. It happens across different machines, environments, and production conditions. This behavior means the powder adhesion is not controlled by visible ink boundaries. Instead, powder responds to a broader interaction field that goes beyond what you can see. What looks like a contamination is actually a system response. The surface condition that allows adhesion exists outside the printed image itself. So powder does not know where it should stick. It simply reacts to local conditions like surface energy, residual influence, and environmental state. That's why adhesion becomes a system-driven result, not a controlled placement. Now let's look at why this happens. Powder particles attach based on surface energy and local interaction conditions. Even in areas without visible ink, the surface may still allow particles to attach. The film surface is not perfectly uniform. Small variation in coating can create zones with slightly different attraction behavior. At the same time, ink influence does not stop exactly at the edge of the design, where can be micro-spread, misting, or residual presence that changes nearby surface conditions. Environmental factors also matter. Humidity can increase electrostatic attraction or introduce moisture that helps powder stick. And the machine movement plays a role too. Airflow and vibration during powder can move particles across the film surface. Because all these factors exist at the same time, powder does not strictly follow the printed image. It attracts wherever the system conditions allowed it. So this is not controlled by a single factor. There are 5 main variables working together. First, film surface behavior. Small differences in surface energy determine what particles can attach. Second, ink layer interaction. Ink influence extends beyond the visible boundaries and affects nearby areas. Third, powder particles dynamics. Particle size and weight determine how easily powder can move and settle. Fourth, environmental conditions. Humidity and temperature affect both electrostatic and moisture behavior. And fifth, machine movement, airflow, and vibration continuously redistribute particles across the film. All of these variables interact at the same time. None of them work in isolation. From a system perspective, this is not a defect caused by a one issue. It is the result of multiple variables interacting inside the DTF printing system. Powder responds to a constantly changing system state, not a fixed condition. That's why it can appear outside the design area. This behavior is also related to other phenomena, like powder flying and uneven distribution. They all came from the same system dynamics. So in summary, powder sticking where it should not is not random. It is a predictable result of how particles interact with surface conditions. Adhesion extends beyond the visible ink because multiple variables overlap and influence each other. To understand this behavior, you have to look at the system as a whole, not as separate parts. This is not about fixing one factor. It is about understanding how the system actually behaves.